Hello gang, Brainy Nerd Tutor here, and after this short series you'll be solving average mass problems. But, well, what is average mass? Well, any given element can have different isotopes, which means a different number of neutrons. And if you don't know what isotopes are, then I recommend checking out my video on atoms, isotopes, and symbols. So the mass of each isotope is different. Now, if we look at one element, let's say lithium, you'll see that the mass is not a whole number here. And with isotopes, the mass number is often a whole number integer. So this decimal number represents the average mass of all the isotopes. So weighted average. And let's look a little bit deeper at lithium here. So the average atomic mass of lithium is reported as 6.938. And I have the two main stable isotopes of lithium. There's lithium-6 here. Now lithium has 3 protons. That's what makes it lithium. Any atom with 3 protons is lithium. Here are the 3 protons. And to give it a mass number of 6, it needs to have 3 neutrons so that there's 6 protons and neutrons together. That's the mass number. Here we have a mass number of 7, so we need another neutron in order for it to be lithium-7. And the percent abundance of these two stable isotopes is reported as 7.6% of lithium-6 and 92.4% of lithium-7. And the average mass equation, we're going to calculate, based on these percent abundances, we're going to calculate this average mass reported on the periodic table. So the average mass equation, average mass, I'm not going to say atomic mass just to keep it short. The average mass, and there's slightly different ways to write this, but they're all the same. Fractional abundance of isotope 1 times the mass of isotope 1 plus the fractional abundance of isotope 2 times the mass of isotope 2. And the fractional abundance is equal to the percent abundance, it's supposed to be an N, abundance, divided by 100%. So it's just the percent as a decimal. Now, if there's more than 2 isotopes, we would add fractional abundance of the third one times the mass of the third one, and so on. So let's calculate what this is. So the fractional abundance is, here F1 is 7.6% divided by 100%, which is 0.076, no units, times the mass. That's just the mass number of 6. Now technically it's 6 unified atomic mass units. I have a video introducing unified atomic mass units, but we could just put 6 there if you want. And then the fractional abundance of the second one is 0.924 times its mass, which is 7 U. And if we plug that into the calculator, 0.076 times 6 plus 0.0924 times 7 is 6.9 U. So there we go. So it matches up there. If we had greater precision in the abundance, we would get greater precision and closer to the true value. So that's it for introducing the average atomic mass and providing a brief example. So check out the other videos in this series to see how else it may be used. Cheers.